Good afternoon, dear participant, and welcome back to this 12th session on parallel computing and code optimization of ongoing 2-week faculty development program on MATLAB for engineers and scientists, bridging theory and applications. Today, our resource person during this session will be engineer Pickon Majumdar. So first of all, I would like to welcome to all the participants who are going to join this session and welcome to our resource person. But before inviting him, I would like to have a brief introduction about engineer Pickon Majumdar. He is an experienced software application engineer and lighting consultant, having worked with the Elmax system and solutions and Intellect Electric Private Limited. He holds BTech in electrical engineering from WBUT and MTech in illumination technology and design from Jadavpur University. His expertise spans emerging technologies, MATLAB project, virtual lab design, and research engagement. He is proficient in multiple programming languages and he has contributed to various research publication and industry project. So now welcome to engineer Pickon Majumdar in this session and over to you. Now we can start the session.
Thank you, sir. One minute.
So I requested to all the participants during the session, please keep your mic muted and you are permitted to unmute your mic during the session. So whenever you feel any kind of the question and you want to discuss, you can put your question by unmute your mic. So, but unnecessary, please don't mute. Okay. So always keep muted. Thank you. Yes, sir. Your screen is shareable with us. We can see your screen.
Okay.
Sir, can you please increase the font size of your MATLAB so that this will be easy to visible to all the participants?
Yes, sir.
I
will share it. Yes.
Yeah. You can go to preferences.
Preferences or no? I will do that like that way.
Okay. Fine.
Okay, sir. Sir, my screen is visible, sir?
Yes, properly? Sir. Perfect visible.
Okay. Thank you, sir. So good afternoon, all of you. Today, I would like to discuss on the topic parallel computing and optimization. And here I will discuss on how we do the multiple computation to solve a computational problem using the MATLAB and Simulink that I will discuss today. So this is my agenda. I will discuss on how we accelerate how we accelerate
how's everything? How was the weekend? How's everybody?
How we accelerate serial MATLAB code, how we speed up the computations with parallel computing toolbox, and scaling up to a cluster or the AWS using the MATLAB parallel computing server and GPU system. So here, here you can see generally there are two types of computing. One is the conventional or traditional computing, and another is the parallel computing. So generally in traditional computing, what is basically done, the programs are there. Program is written by user, and it will be fed to the system as input, and program will run accordingly. So the computers basically run a program at a time, but the computation time is more in case of traditional computing. But if I discuss, if I want to discuss on the parallel computing, but why we need to write the parallel programs or the parallel computing? Because uh, we have to solve the computational problem as fast as possible, and we have to break down the problem into a smaller independent parts that can be processed easily, processed concurrently by the multiple processors. So here you can see that running multiple instances of a serial program, because while you are process a program, so it will program serially, and it is sometimes it is taking lots of time, and these individual computations is create some problems. So if we combine the individual computation and produces a final output, okay, that will be done by the parallel programming. So multiple instances of a serial program generally not useful. So if I want to run the multiple instances at a time, at that time the system will be much faster. Okay. So here you can see that how do we write the parallel program. One is the task parallelism, another is called the data parallelism. I will discuss one by one, because the main concern is the speed up the computer. Because why we need parallel computing? Because uh, e- uh, we have to distribute the task. We have to distribute the task into the multiple processors, where multiple computing can be possible, and it will reduce the computation time, as well as it will handle the larger or more complex problem, and also it will handle it more efficiently. So they definitely, the multiple processors in come into the picture, which can be utilized, for the parallel computing task, especially for the real-time applications while you are handling different types of problems like machine learning problem, deep learning problem, or the signal processing problem. So at that time, the large amount of data set will be processed through the processor. So there is a huge data, that is a large volume of data, or you can call it as a big data. So that will actually process in the real time, or in the critical situation. So at that point of applications like data analytics, or scientific simulations, or image processing, while if you're taking any image like 4 MB image or 5 MB image, and if you want to process a one single image, you will find out that that image will be read in the form of matrix, where you will see the lots of pixel values. So while you process that kind of lots of image from an image folder, at that time it will take the lots of time. So that's why we write the parallel program. So that's why here you can see that task parallelism, where we can partition or segregate the various tasks to solve this problem among the cores. So there are one will be the single core, one will be the multiple core. So we have to divide the task into the multiple core, so we can process the process any task parallelly. So this is one thing. Another important thing, the partitioning of the data. Okay, so because as we had handling the large volume of data, large volume of data, at that moment a single processor cannot be handle that kind of huge volume of data, process the data at a time. So we have to partition the data in such a way that we can process it easily, and we can solve the problems among the cores. And here you can see that each core carries out the similar operations on its part of the data. So one is the task parallelism, another is called the data parallelism. And here it is very important that the codes or the processors is a key component, because for the computational unit it is required, because these processors or these codes is basically the basically helps as a computational unit, which basically executes the instructions, especially the codes which is basically useful for the multiple processing units within a single processor. And also in this type of applications like parallelism, basically here we have to execute the multiple tasks simultaneously. So at this point of time, this type of task parallelism or the data parallelism is important. Okay. So now here you can see that yes, codes usually need to coordinate their work. Okay, just a minute, one. So here is the coordinations, basically codes. Already I have told you that codes is basically multiple processing units within a single processor. Okay, and here they need to coordinate their tasks, basically the communication, or in case of load balancing, or in case of
मैडम मैं
synchronization. Because
बोल रहा हूँ।
hello,
हाँ जी मैडम, आपने आज के लिए मीटिंग फिक्स करवाई थी।
hello.
कौन से मैडम? हाँ जी
Okay, so here you can
Please
see
continue.
that yes. So here you can see that the coordination. If I talking about the coordination is based on the load balancing, synchronizations, and communications. The main, what is the problem is that problem, or the main challenge is that um, um, main challenge is that because while you are handling the large volume of data, so at that time the multiple processing is required. Okay, so and also and in case of multiple processing, the program will become easier, and the line of code should be less. So, and also important challenge, the another challenge is the distributed memory. Okay, so first of all, the each processor has its own local memory, so they communicate through a particular network. So communication is more important, because one or more ports actually send their signals or send their current partial sums to another core. Okay, and also the load balancing, because the work should be distributed properly, so that it will handle the work, okay, easily. And also distributing the workload um, equally or evenly across the processor. This is basically the load balancing. Okay, and another is basically the synchronization. Synchronization is basically the coordination coordination or coordinating the actions of the multiple processors. So this is important that because here you can see that because each code works at its own pace and make sure that each code do not get too far ahead of the rest. Okay, so here in case of synchronization, you can see that the multiple cores actually coordinating with each other to solve to perform any action. And also the communication is much more important because here the transfer the data between the processors is much more required. Okay, so here the two major classes of parallel programming model. One is the shared memory and another is called the distributed memory. Shared memory is that where the multiple processors actually share their same physical memory. Okay, so this is called the shared memory. And here in case of shared memory, what is the advantage of the shared memory? That you can easily program it, or efficient data sharing can be possible. Um, Here you can see this is the shared memory architecture. Here the shared memory architecture. This is CPU core 1, this is CPU core 2, and this is CPU core 3, and this is the memory bus. And collectively, you can see that this is the shared address space of the memory. Here, all threads can see a single shared address space, and therefore they can see each other's data. Okay. Okay, it will share. So basically, in case of shared memory, multiple processors actually share their same physical memory. But the disadvantage is that is the scalability limitations. Okay, and also the memory contention. So uh, that's why we can rely on the distributed memory architecture. So this is the distributed memory architecture where you can see that each processor has its own local memory. So here you can see that computer node 1, this is compute node 1, compute node 2, and up to compute node n. So see node 1, node 2, node 3, node 4 up to node n. So it will compute each memory performance, and each processor actually has its own local memory, and they communicate through a network. So here you can see that network interconnect. So these memory, this is bidirectional. This local memory can communicate via this through a network or via this network, and they can communicate with each other. So the main advantage of this distributed memory architecture is that each processor definitely has local memory, and of course it is scalable and the fault tolerant. But here the main challenge or disadvantage is that these are basically more complex in programming, or while it is communication, because at the time of communication uh, uh, is sometimes it will facing some problem. So so this type of problem that it will face, and also the while it is uh, collectively send the data at that time, some problems will happen. Okay, so this is basically the distributed memory architecture. Okay, so here you can see the clusters. Basically, while you are handling the big volume of data, I think you have known about the HDFS system, that is the Hadoop distributed file system. At that time, basically the data will be distributed among the clusters. Okay, so there will be the one master node and another will be the slave node. Okay, So similarly, these clusters is nothing but a small node or small computer, okay, which is a collections of the commodity system, and these will be connected uh, via network. Okay, so this is, yes, here it is written that nodes of a cluster are individual computers joined by a communication network. Okay, so here you can see that I mean, the while I have talking about the master slave architecture, where there will be the master and others will be the slave, and if I want to preserve any informations of a user, like suppose any bank details or any other informations like age, its service, etc. So what will be the data will be not only preserved in a particular cluster, but it will be distributed on another cluster. Okay, so as per request, the node will share the data via communication network. Okay, so this is the basic of the parallel computing. I think in brief I can tell you that parallel computing is basically a powerful tool for solving any kind of problem, complex problem, basically a complex problem very efficiently. And also the main important thing is that the problem like suppose if I am talking about the applications like data mining or image or video processing or machine learning or deep learning applications, or for bioinformatics application or financial modeling or and risk analysis. So at that time, in this type of application, the parallel computing and its simulation is very much required, because here it is required to write the lots of codes, lots of training is required to create any model. At that time, that kind of parallel computing system is required. I think this is the brief overview of theoretical overview of parallel computing. Now I am moving to the MATLAB part. Just a minute. Okay. So I think this is clear that what is parallel computing, or what is its advantage, what types of parallel computing is there. Okay, main thing is that because we want to speed up the workload across the multiple processors through this parallel computing, so that the computation time will be less for complex problems, and also for the scalability to increase the efficiency, or if we optimize the resource utilization. So at that point of time, the multiple processors is required. So, and also for this type of complex real-time applications, this parallel computing is parallel computing is helpful. So this is all about the parallel computing. And next, I like to proceed through MATLAB software. Okay, so here you can see that there are some functions. There are some functions here. You can see that all. First, I want to show you the platform. This is my platform. Here you can see that home, plots, apps, app section is there. Okay, so this is my MATLAB desktop environment, where you will see that at the left hand side you can see the current folder. From here you can access your files and folders, or different files. Okay, it may be CSV file, it may be .xlsx file. Also, whatever be my MATLAB script file or the MLX file, that will be easily accessible from here. Next is the command window. Command window is that where you can write your command at the command line. Yes, it is here that you can write your command at the command line. And at the right hand side, you can see the workspace, where you can see that variables is there. Okay. Here you can see the variable name and variable value. Okay. So these things you can see from here. And here the another important feature is the live editor. Live editor is that it is a little bit the different, or you can see the updated version of the script. Okay, here you can write the text as well as you can write the text. You can add your hyperlinks, images, etc. As well as there is a text section, another is called the code section. So here you can see this is the code section, and as well as you can add some control features, like if you want to add any button or any drop down list or edit field, so that you can add. Or also you can add some apps, like for the pre-processing of data, cleaning and missing data, etc. For pre-processing the data, some apps you can use. For plotting purpose, you can use the create plot, or all for importing the data you can use that one for data import or app. Okay, so these thing you can use, and you can, yes, of course, after completion of your work, you can publish it among your students and colleagues. Okay, you can export the whole result, I mean the code as well as its outcome in the form of PDF, in the form of LaTeX, or in the form of Word format. Okay, so that is the beauty of this live script. Okay, now I am moving to my MATLAB code. Okay, so first is that whatever suppose this is my program. Okay, this is my program. So if I want to access that program, I have to copy the path and paste it here. Copy the path and paste it here, so that I can easily access that kind of file. Okay, or we can add path. Okay, so there is an option that is that to add path, there will be the option. You can add path in the working directory. Okay. Okay. So first thing is that, yes, of course, the what is the prime objective? Prime objective is that first here it is written that try using function instead of scripts. So generally what is happening that we are trying to write lots of line of codes, like for loop, for any kind of conditional statement, or any type of, suppose I want to create any array, or display any value. So at that time, or for iterations purposes, I can use some for loop. Okay, so at that time I can write the lots of codes in the script. But instead of that, suppose I want to create any calculator. Okay, calculator. So at that time there are different types of functions, like logs function, log function, some addition function, trigonometric function, division function. So there are different types of functions are there. So instead of writing codes, if we generate functions, if we create any functions, then the function will be generally faster, and the program will be executed in a faster manner. And also next thing is that instead of resizing arrays dynamically, we can pre-allocate memory. Pre-allocation, why pre-allocation is required? Because the primary memory, sorry, I mean the parallel memory allocation basically deals with the problems of the memory allocation in a multiple threaded applications. So while application running on a multiple CPU architecture, at that time some problems maybe arise. Okay, so instead of resizing array, because I am creating any array, no, I want to resize the array. Okay, so instead of that, we can pre-allocate the memory. We can for instance, we can run 2 threads on a CPUs, and we can perform it with the another CPUs. Okay. Next is the you can create the new variables rather than assigning the data. Okay. Of a different type of existing variables. And next is the vectorize. We can use matrix and vector operations instead of for loops. This is very important because instead of for loops we can use the matrix and vector operation. Why vectorize or vectorization techniques is required? Because it actually exploits the ability of modern processor to perform in the multiple operation model. Okay, so it will perform the multiple operation model simultaneously on a given sets of data. So if you have a large data set, okay, so you can create the numeric matrix or the vector in the vector or in the vector format instead of for loop. Okay, so I can create or generate the data by using the for loop, but instead of that we can create the data elements sequentially, and that can be that can be actually performed on the multiple using the multiple operations. Okay. uh, and avoid printing too much data on the screen. Okay, so avoid printing means we try to avoid or execute, because if we try to print on the data on the screen, suppose every time I write disp disk. Okay, disp is the command for displaying any outcome or displaying any value, or if I want to print any data, if I want to use the print command, so every time it will show the value of the data, so that will increase the computation time. So we have to avoid printing, and we have to avoid the programmatic use of cd add path, rm path when possible. Okay, so here you can see that a simple example why we are talking that this is the inefficient code. First, here you can see that tick, tick basically the you can see that tick is basically the code tick which basically measures the elapsed time. Okay, so tick function basically records the current time, and talk is basically the another function. Here you can see the talk is basically uses the recorded value to calculate the elapsed time. Okay, so the peak function basically records the current time, and talk function is basically record to calculate the elapsed time. Okay, so this is the two functions. Now here this is the array. Simple thing, I can use the multi-dimensional, I can create the multi-dimensional array like a matrix, 1 space 2 space 3 4 space 5 space 6 and 7 space 8 space 9. Okay, so and after that I can create like that way, that for I1 colon 9 and bi and end for 1 colon 9. For 1 colon 9, if I write 1 colon 9, say then 1 2 3 4 5 6 7 8 9 is like that way. And here if I write it okay, so like that way I can run a for loop. Okay, so that if I want to doubling the array, suppose here I want to multiply a, this is a having this is a 3x3 matrix. Okay, if I am talking about the 3x3 array. Okay, and I want to double the value of array, each value of array, then I can create the for loop like that way. So bi colon 9 and every value of a will be doubled, and it will create a new array where the elements will be doubled. Okay, so this is the one method of this is a method of traditional computing, okay, traditional programming. Or here also you can see that getting number of spaces in a string. A big brown dog jumped over the lazy fox. So if I want to count the number of spaces in a string, so this is the string written in the string format. So here I can again perform the for loop technique, okay, and here I equal to 1 colon length a. So a big brown fox jumps over the lazy dog. So this is written in the string format. So if I write the length a, so you will get the length of this okay. And after that if I want to count, so this is the conditional statement. So if a within bracket I equal to space, so this is the space, okay. So I want to find the number of spaces. So if it will find the space, then the count will be increased. So count equal to count plus 1, then it will end. So every time I have to end the end this loop, okay. So this end is for the for loop, and this end is for the if statement, okay. Next end, then count, and then top, okay. So this is my, I think it is, just a minute, I have to, I think this is clear. This is our traditional programming, okay, traditional programming. But if I am talking about the better code, at that time, if I talk 1 space 2 space 3, so I can write here instead of that 1 colon 3. 1 colon 3 means 1 space 2 1 1 2 3. Similarly 4 colon 6 means 4 5 6, and 7 colon 9 means 7 8 9, like that way. Similarly, now if I write b equal to 2a instead of this for loop, if I write here b is equal to 2 into a, then the value will be updated. Similarly, s is my my string value, okay. So here a big brown fox jumps over the lazy dog. Now I want to find out the spaces in a string, number of spaces in a string. So this is my string value, and I want to find the number of spaces in a string. So every time I have to find that is there any space, okay. If there is any space, so I have to count the space and sum it, okay, and whatever be the sum will be executed at final. So space is basically returned if I am writing the space of s, okay. And if this s is a character array or the string scalar, then the elements of s are logically one, where the corresponding characters are space characters. So if there is a space character, it will considered as logic 1, and this logic 1 will be logic 1 means logically 1 or the true, okay. And if there is a no space character, then it is logically 0, I mean the false. So this a space basically recognizes uh, the white space character or the Unicode white space character, okay. So here you can see that if I want to, so if I compare it, then I can compare it that this is my time 1. Wow, for the conventional time I can find out the conventional time, while the sorry while the program will be end. So after that I can find the total elapsed time. I can calculate the total elapsed time. This is my time 1, and here I can calculate the time 2 after completions of this code, okay. This is my time 2. Now this is speed up time 1 by time 2, okay, time 1 by time 2. So how much it will be speed up, that I can find out from here, okay. So I think it is clear. It is very easy to understand. Similarly, detect the potential issues of the MATLAB code analyzer. So the code analyzer in the MATLAB editor checks your code while you are writing it. Okay. So the code analyzer basically identifies the potential problem and recommends the modification to maximize problem. Similarly, we can use the here you can use the tick function. Okay, tick function that is important. So that actually stores the current time current time and here I can assign the I equal to 0, y equal to 0, and for t equal to 0 colon 0.01 colon 1.1, and after that I iterate it. I equal to I plus 1 and yi is equal to sine t. Okay. So then we can plot the curve. Okay, this is my y value. Okay, and finally we can find out the elapsed time. Okay. So next with the pre-allocations, already I have told you about the pre-allocations because pre-allocation is required for the memory allocation. You can initialize an array using the final size required for that array. Okay. Okay. So here you can see that there are two loop particularly pre-allocation helps you to avoid dynamically resizing arrays, particularly when the code contains for loop and while loop. Okay. So so here you can see that here the for loop is there. Okay, t equal to 0 colon 0.001 colon 1, I equal to I plus 1, y equal. So now this is the pre-allocation time. Pre-allocation time that is that will be that will be counted or calculated after this program. And what will be the percentage difference that will be calculated from here. Okay. So here you can see that this is my conventional method. Okay, this is my conventional method, and after the pre-allocation you can see the pre-allocation time. Okay, pre-allocation time, and see the percentage difference between the pre-allocation time and the plain time and the pre-allocation time. Okay, and after that you can print the value here. Okay, so you can print the value. So if you want to run the section, okay. So basically here you can see the different types of optional MATLAB profiler, okay, which basically use for this type of application, like code analyzer or the code compatibility, data cleaner, experiment manager. So these are basically the basically used in the MATLAB profiler. 1 minute. So I think from here, I think you can understand that this is my traditional computing, and this is for the parallel computing. Okay. So to enhance the performance, to reduce the computational time, we can here you can see, yes, here you can see the result. So here you can see that this is my count, and this is the time taken for the traditional computing. So time taken, time one is 9.6 sorry 9.6721, and here the time taken is 0.3522. Okay, so this is my uh, time one versus time two. I mean the how much speed will be enhanced, so that you can calculate from here. Okay, so here the time taken is more for the traditional computing, but while you can write the better code in a better manner, so you by using the space command. So space command, or by using the colon, you can see the speed up, how much speed up will be there. So that thing you can find out from here. Similarly, here in case of this issue, while we are using the MATLAB code analyzer, so at that time you can see we can see that the plain time is 0.4.991. 0.4.991. This is my plain time. Okay, just a minute. So this is 4.91, but this is after pre-allocation. Okay. So while we contain the for loop or while loop, so for loop and while loop, at that time we can use the pre-allocation, and at the time is taken is 0.0471. Okay, so it will be 10 times higher, 10 times lower. I mean the plain time is 10 times higher than this method. Okay, memory pre-allocations method. So that's why we can use the pre-allocation technique. Okay, and next is the vectorization. This is the vectorization. Vectorization is basically that I have told you that it is the process. It is a process of converting the code using loops to matrix or the vectors operations. So this vectorization is also needed, and this is the technique to perform where the multiple operations can be done simultaneously on a set of data. Okay, so I think from here you have understood that one. And next is the profiler. So you can see okay. So if you want to use the MATLAB profiler, either you click on the MATLAB profiler from the either you type the profiler in the MATLAB command, or you can open the MATLAB profiler, and after that you can and compare the total time and the self time. Okay, so that thing you can compare. Okay. Okay, I will jump into the next part. Apply vector. Okay. So this is the I think this is understood that what is the key takeaways? Key takeaways that is the better programming that actually lead to the faster code, and you can use the vectorized operations instead of loops, and also you can use the built-in functions. So here you can see that this is the better code practice where you can speed up your program. Okay. Okay. And a MATLAB profiler basically used to analyze the execution time and find the bottlenecks. And here you can generate the MEX code, MEX code, or the C++ code or CUDA code from a particular function. Okay. 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 Now, it is very important that what is parallel computing. Already I have told you that one is the traditional computing, another is called the parallel computing. In traditional computing, here you can see this is the example where we can use the par for option on the multiple core CPUs. Instead of for loop, we can use the par for. Okay, I will show you. Okay, here you can see that this is the traditional computing. If I am considered this is my processor, okay. So here basically this processor actually processing the task one after another. So here you can see it will the queue of new instruction coming in. So this is in queue. Okay, so it will processing the task one after another using a single processor. This is one processor, only one processor, or the single processor. So that's why it is called the sequential computing. So this traditional computing is also known as the sequential computing, where the task or the task basically process sequentially one after another. Okay, but in case of parallel computing, what is happening, that multiple processors are there. So here you can see that there are two processors, P1 and suppose P2. The two processors are running simultaneously. Okay, so here you can see in case of parallel computing, uh, the problems into breaking down into the smaller and independent sub problems, and that will be assigned to this particular processor. This is the P1 processor. If I consider this is my P1 processor and this is my P2 processor, and if the problem is given, then the problem is subdivided or breaking down into the smaller problem and given to the independent, giving them independently to that processor. Simple thing. Okay, and it will process simultaneously by the multiple processors. And simple thing is that what is that simple thing, that while it is processed simultaneously, it will take less time. Okay, in comparison with the single processor. So basically in single processor you can see, in case of traditional computing, you can see that there is a single processor. The sequential execution will be there, and also it will only deal the small scale problem, not the large scale problem. But while it will deal with the large scale problem, if I divide into the I can divide into the small scale problem. Okay, if there is a multiple processor, then I can divide it into the small scale problem. But if there is a single processor, I cannot divide into the small scale problem. Okay, so that's why it will only deal the small scale problem. But for the large scale problem, the problem is divided into the each processor. Okay, so the simultaneous executions can be possible, and it will basically suitable for the intensive or the large scale problem. Okay, so this is important. And why and when the parallelization, this is very much important, very important, because the primary reason of parallelization is to accelerate the computation. Simple thing. Okay, acceleration. So we have to basically, here you can see that save time by distributing task and executing this simultaneously. I have already told you. And solve big data problem. If you have a large volume of data, large variety of data, large volume of data, so we have to distribute the data properly. so that to solve the big data problem. And also these actually deal with the multiple processors or the multiple cores, which basically reduce the overall execution time. While it process through the processor, it will reduce the computation time. It will reduce the execution time, overall execution time. Okay. And next is the take advantage of your desktop computer resources and scale up to the clusters and the cloud computing. Already I've told you, basically in case of big data problem, in case of big data, basically we are dealing with the HDFS by Hadoop distributed file system. At that time, we can divide it into the small clusters or small nodes. So we definitely, this is the advantage. So for this advantage, we can distribute the data into the small scale nodes or small clusters. Okay. Okay. Next, this is now here you can see, yes, this is my client, this is my MATLAB worker. So this is the parallel pool. Okay. So here you can see that parallelization is beneficial only if the simulation takes a lot of time or we have the big data to deal with. So not everything is parallelizable. Okay, so here you can see that some terminology, that is the MATLAB workers or the MATLAB client. So these are the MATLAB workers which is present in the parallel pool, and this is the MATLAB client. Okay, so the client is basically the master who basically instructs the worker with the parallel language function. Okay, and MATLAB workers is basically the MATLAB computation engine that run in the background. Okay, I think it is visible properly. Run in the background, without graphical desktop. So this MATLAB session, you interact with the MATLAB client. So I think you have understood that this is simple thing. This is my master and this is my slave, or that this is the client or this is the MATLAB worker in terminology. Okay. So basically, what will be the problem assigned to the MATLAB client can be divided into the independent subproblems, and it will be assigned to the MATLAB clusters. So these subproblems should have minimal dependencies on each other. Okay, and the computational workload should be significant for small tasks. Okay, so if there is a parallelization, the overload cannot be possible. Okay, overweight or overload cannot be possible. So there are multiple cores or the processors which are available, and using these parallelizations we can of course we can reduce the computation time and also the execution time, and also the it will be more energy efficient. Okay. So here you can see that this is my parallel computing toolbox. So this is my multi-core desktop, and this here you can see that core 1, core 2, core 3, core 4. Here you can see, and 1 minute. And this parallel computing toolbox provides the ability to distribute the MATLAB code across the multiple MATLAB processes. Okay. So important thing is that here the system requirement. Okay, the maximum system requirement for one MATLAB worker, maximum of one MATLAB worker per physical CPU are recommended, and 2 GB RAM per MATLAB worker is recommended. Okay, so if you are a Simulink, so if you are using Simulink, only 4 GB RAM per worker is recommended. So one is MATLAB client, and another is the MATLAB worker. So for MATLAB worker, physical CPU, 2 GB RAM, 2 GB RAM for the MATLAB worker, and if there is a Simulink, because for model-based application, model-based design and simulation, 4 GB RAM is required. Okay. Next thing is the supporting local scheduler, supporting local scheduler. So local scheduler is that it is a component, or it is called as a software component that is responsible for managing and executing the task on a on a single computer. So here you can see, so what is the requirement for supporting the local scheduler? Minimum 5 GB disk space. Minimum 5 GB disk space is required for the is recommended for the for the system. Okay, is recommended to accommodate the temporary data directories. Okay, and if you are a Linux or Macintosh user, then it will create a large parallel pools of workers. So it is recommended that you adjust your operating system limits. Okay, system limits. So there will be some sequence system requirement. So basically here it is the basically the intermediate system or intermediary between the operating systems and the applications. And here it is important to determining which process or which thread will be allocated to the processor at a given time. Again, I am telling you which process. Here basically it is at intermediate stage. Local scheduler is basically the intermediate stage where it will be there between between operating system and the applications, which basically determines which thread or the which process will be allocated to the processor at a certain time. Okay, next, the requirement of the GPU computing. Okay, GPU component. So here important thing is that here it is written that minimum 5 GB disk space is recommended to accommodate the temporary data directories. Okay, data directories. And here the requirement of the GPU. So in case of local scheduling, different types of work is there, like process management is there, or maybe the resource allocation is there, where resource allocation assigns the CPU time, memory, etc. But in case of GPU computing, it will perform the same operation on the multiple data points simultaneously. So that's why this is known as the SIMD. SIMD stands for single instruction multiple data. Single instruction multiple data. Here you can see, just a minute. Here you can see, yes, this is my SIMD. SIMD is single instruction multiple data. SI stands for single instruction and MD stands for multiple data. MIMD stands for multiple instruction multiple data. Okay, have you understood that one? SP stands for single program. So so here in case of GPU model, while GPUs basically excels at performing the same operations on the multiple data points simultaneously. So if I consider the SIMD architecture, then at that time the each thread should be executing the same line of codes at a given clock cycle. Okay, each thread will be should be executing the same line of code at a given cycle. And here multiple instructions, so each thread or the process could be independently running a different line of our code instruction concurrently. Okay, so there is a multiple instruction. So if there is a multiple data is that each thread or the process could be operating or accessing different pieces of data from the memory concurrently. So in here you can see the requirement of the GPU computing. So where it is applicable, basically where the deep learning application. Okay, so deep learning applications, or for the embedded system, it is required to generate the CUDA enabled code. Okay, The CUDA-enabled NVIDIA GPUs basically compute the capability of 3.0 or higher version. Okay. Okay. Next thing is that here you can see the requirement for scaling across the multiple computers in a cluster. So basically here important thing is that this is the GPU computing. In case of GPU computing, the main important thing is that GPUs can deliver the substantial speed ups for the different tasks. Okay. And this SIMD architecture basically handle the large data set. Okay. So here multiple computers in a cluster or cloud that actually handles the multiple, handle the large data set. Okay. Large data set. So this can be easily done, and also for high computation performance, the GPUs are more reliable, more cost effective. Okay. Now next is the parallel pool. What is parallel pool? Parallel pool is basically, here it is written that by default a parallel pool starts automatically when you need a certain parallel language features. Basically the parallel pool is a collection of computational resources, okay, where multiple processors are there or multiple cores are there that can be execute task concurrently. Okay. So the parallel pool is basically the fundamental concept of parallel computing that actually enable the efficient distribution of workload across the available hardware. So here you can see that you can see, find out the start parallel pool. Okay. So if you want to start parallel pool, then there is a function that is called parpool, PARPOOL, pool, parallel pool, PARPOOL, that is actually parallel pool. So first here start pool and then the parallel preferences. Okay. So first the parallel pool is created and specify the desired number of workers, or the desired number of workers means desired number of processors or desired number of cores that should be utilized. Okay. So first is the creation. Okay. So next is the task distribution. So next is the task distribution. So which task or which subproblems are there, so that should be divided, or that should be assigned to the workers. Which workers? MATLAB workers. So here it is written the number of workers. Number of workers means what? Here you can see that these are basically the MATLAB client and these are called the MATLAB workers, right? So here first is the creation. You have to create the parallel pool, and after that you have to specify the desired number of workers or desired number of processors to be utilized. And next, that what will be the task? That task should be subdivided into the sub problems, and it should be assigned to the MATLAB workers in the pool. Okay, in the pool. Next is the concurrent execution. Okay, next is the concurrent execution, where the workers process their assigned task simultaneously. Simple thing. Okay. So here in the programming interface, you can start and stop the parallel pool programmatically by default settings, or specifying alternatives. Okay. So to open the parallel pool based on your preference setting, you can write like that way. So number of workers, suppose here it is 3. So number of workers is 3, and pool is equal to parallel pool. So par PAR pool within bracket number of workers. So here, what is the code written here? Just a minute, I have to increase that. If is empty, if is empty, GCP within bracket no create par pool local comma 4 end. So what does it mean? So basically this is the MATLAB code. This is the MATLAB code which is designed to ensure that the local parallel pool with 4 workers, local parallel pool. So that's why I have right here LOCAL, local local parallel pool. Okay, so par pool is the parallel pool. This is the local parallel pool, and comma if the number of workers, MATLAB worker is 4, then it is called as 4 workers. Okay, and it should be created if it should be created, and after that we have to close the if statement. Okay, we have to close the if statement. So you can run the command. So is empty, what is the is empty? Because this part actually check if the parallel pool is concurrently running or not. Okay, so and the GCP no create. What does it mean, GCP no create? This GCP no create function basically returns the empty object if no pool is active. Okay, so here is empty function is basically checks if the object is returned empty or not, and here GCP no create function basically returns an empty object if no pool is active or not. Okay, just a minute. One minute. Yeah. Okay. So next is the par 4. So here it is written that par 4. Par 4 is basically the MATLAB. I mean the MATLAB code. You can say it as a MATLAB code or MATLAB construct designed to execute any loop iteration. I mean, I have told you that instead of for we can use the par 4 for parallel computing application. Okay, so if we want to execute the loop iteration in parallel across the multiple workers, so here 3 workers or the 4 workers are there. So if you try to iterate the loop and want to execute the loop in a parallel pool, so at that time you have to use the par 4 function. Okay, par 4 function. So it is a very powerful tool that is basically useful for any different types of intensive tasks, which actually breakdowns into the independent iterations. So for loop, I think you know that it is useful for the iteration. So similarly, if the task is really intensive or really complicated, it will be break down to the independent iteration. Okay, so this is all about par pool, is empty, par 4 function, etc. This is the par 4 function. Okay, par 4 or the batch command. Okay, Just a minute. Just a minute. So here you can see, yes, this is that what I want to say, that this is my MATLAB client and this is the MATLAB worker. Okay. So generally, while I want to run any for loop, so I can write like that way: for I equal to 1:5, yi equal to my functions, whatever be my functions, within bracket my variable I, and then end. But while it is while the worker is working in the parallel pool, if there is a complex task or the heavy task, then this perfor function basically splits the execution of for loop iteration over the workers in a parallel pool. So here I can write, instead of for, I can use perfor I equal to 1:5 yi, my function, my for. So these are same. So only this simple for loop is converted into the per for loop. Have you understood that one? So I think it is clear that simple for loop will be converted into the per for loop for this parallel pool application. Okay. So generally, if you want to know the documentation of per for loop, just type 1 minute. Just type doc equal to per4, doc per4. Or go to this site. I think this is visible. This is the documentations of parallel computing. Is my screen is visible? Parallel computing documentation. Is my screen is visible? MATLAB documentation page. My documentation page is visible, sir. So this is the examples interactively run run loops in the parallel using the power for. Okay, so you can find lots of examples here. So you can see that lots of examples here. So how you can write? So this is tick, and then your variables names are then zeros. Then you can write the, instead of for loop you can use instead of for loop. So here same thing is written. So you can measure the tick and the talk to measure the time elapsed. Okay, and after that you can see that while you run that script, it will take much more time. Okay, the 31 second, almost 31 second. But while the four workers are there, and if you type the per for loop, so at that time you can see the elapsed time is 10.76 second. Okay, almost 3 times less. Okay, so that kind of example is available. Okay, I am sharing this. Okay. Now, okay. So this is all about the serial computing, where code is executes in the sequence, and when the codes is executed in parallel, then it is called as the parallel computing. Okay. So why parallel computing is useful? Simple equation is that, suppose m second order differential equation of a mass spring damper system, f equal to d2x plus dt2 plus b c dx dt plus kx equal to 0. If this is my equation, and I want to create the surface plot from here. Okay. So by using the parallel computing, if I distribute the simple, I want to compute the force. Okay, I want to compute the force. So if I distribute the work within the number of workers, suppose there will be the 3 workers, there will be the 4 workers. So if the number of workers is more then it will be speed up. Okay, speed up. So if I compare it, then you can see that by using the parallel computing, it will be much faster. Okay, simple thing. Okay. So why types of problems can be? So I think almost it is discussed that why that kind of what types of problems can computing to be used. Okay, just a minute. When to use parallel computing? Okay. So when to use parallel computing? So here you can see here you can see some example like image processing. Okay. So image processing. Suppose I want to I have a data set, image data set. Okay. So and I want to I have a batch of images that I want to process through the for deep learning applications. Okay, so batch processing, batch image processor. Okay, so is required. Okay, I want to convert the image into the grayscale image or recolored image. Okay, so at that time, this is the paper.jpg. Okay, so if I have a 100 or 200 number of images like that way, okay, and if I want to convert it, so at that time will be taken. Okay, similarly, in case of statistics machine learning applications, where we apply different types of machine learning models like k-means clustering, or the clustering techniques, or the regression technique, or classification technique. Okay, so generally for the clustering techniques, where we applied the hierarchical clustering or agglomerative clustering. Okay, so there are different types of methods while we apply for the machine learning applications. Okay, so then definitely we have to enable the parallel computing process. Okay. Similarly, for the semantic segmentation, here you can see that this is the semantic segmentations, where we have to find out the lanes or the roads. Okay, by using the real-time camera, by using the camera. Okay, so from that camera, I want to recognize the pedestrian. I want to recognize the pedestrians, or different sign, the traffic signal, lanes, roads, so etc. So at that time, the neural network training is much more required. Okay, so I think you know that in case of deep learning applications, there are 3 layers. One is the input layer, another is the hidden layer, another is called the output layer. So in hidden layer, you will find that feature extractions and classifications, these 2 things can be done, and lots of data sets are required for the feature training. Okay, so so here this is at that time, the parallel computing is much more required. While we train the system. Suppose I have a even if I have a I want to build a network, or I have a pre-built network of a pre-built any deep neural network. Okay, so if I have a large volume of images and I want to process it and I classify it at eventually. Okay, suppose I want to classify the road, I want to classify the pedestrian, I want to classify the trees or houses, I want to classify the signals or the traffic signs, etc. So at that time, from a real-time video or from the for different types of images, so it is required to get the uh, get the good accuracy from here. Okay, so to get the good accuracy, first you need to process the uh, good data set. Okay, not no validated data set. Okay, so so this is important. So at that time you have to process the big volume of data, big volume of image data. Okay. Similarly, for the signal processing, like for speech recognition technique, okay, or the voice recognition technique. So at that time, GPU enabled fast Fourier transformation filtering or cross correlation or burst simulation. So these are basically the application areas. Even for the computer vision's applications, where we basically use the object detectors. Okay, object detections. Okay, like to extract the key points or feature extractions or the clustering. Okay, or so these are basically the examples. Okay, basically the examples, and you will find there that there is a parallel computing toolbox is required. Okay. So I think I have already discussed about the multi-core CPU. Okay, multi-core CPU. If there is a multi-core CPU, means the cores having the more than one. Okay, so these are called multi-core CPU: core 1, core 2, core 3, and core 4. So in case of that, the MATLAB code runs on one core. Okay, why? So for in case of numerical functions like FFT or the for the eigenvalue or SVD, these are basically the multi-threaded. Okay, multi-threaded. And yes, here you can see that yes, for parallel computing application, uh, instead of for we can use par for parallel for loop. Okay. And similarly, parsim is important. Parsim is important. Sim is for the simulation purpose. Okay, simulation purpose. So instead of sim, we can use the parsim. Okay, for parallel simulation. Similarly, for offloading computation, we can use batch. Okay, batch is basically for the batch processing purposes. And for GPU accelerated computing, we can use the GPU array. GPU array that is basically useful for the GPU computing. Okay. I think it is clear. So here, I think we for the parallelism we can see that MATLAB and MATLAB task, the extensive MATLAB task can be distributed among the workers. So here you can see that if there are 3 workers, here you can see 1, 2, 3 workers. The time is taken more or less, okay, but not too much long. But if it is sequentially driven, okay, sequentially driven, I mean the task is executed one by one way, so the time will be taken. So if the task will run parallelly, okay, so if you iterate in a parallel manner, then it will take the less time. So already I have told you that parameter sweeps or the Monte Carlo simulations, this is basically the uh, example of parallelism. Okay, so already I have given that kind of example, a equal to zeros 5, 1. So that is easily. So while I have performed this task, same thing, the program is same, but what is the difference? That is the instead of for we can use the par for. Okay, instead of for we can use the par for. Okay, so I think it is clear to you. Okay. Now this is for the parameter sweep. Just see here the video. You can see the video. This is basically the surface. As you know that this is basically called as the surface plotting. Okay, surface plotting. So here it is written that use perfor to perform a parallel sweep. Okay, I just see the example. I am showing you that the elapsed time here it is 38 seconds. But if I changing to the perfor, while I have used the for, then it will take the 38 second approximately. But if I change to perfor, okay, then it will take only 11.16 seconds elapsed time. Okay, so now I am showing you that one. If the example is there, I will show you. Uh, okay. So this is the convert for loop into the per for loops. Okay, this is the another example. Okay, so you can convert into the per for loops. Simple per for x equal to 0 colon 0.1 colon 1 disp and then end. Okay, so if there are no nested loop, because here you can see you cannot nest the per for loop inside the another per for loop. So the reason is that workers in a parallel loop cannot start or access the further parallel pools. Okay, so this is important. This is important, very much important, because in case of for loop we can create the another for loop. So this is called the nested loop. But here in case of per for loop, you cannot access the another parallel pools. Okay, so here because of parallel processing, processing incurs overhead, you must choose carefully whether you want to convert the inner or outer for loop into the per for loop. Okay. Okay, so if you want to generate any random number, simple thing, any random number. So here you can see RNG default n equal to 100, capital N equal to 50, and we can create the zeros in comma capital N. Then you have to find the elapsed time tick, then tick bytes GCP. Okay. Next, you can use the per for command like jdx 1 colon n and extract the large value of 1 by jdx row vector and t jdx comma idx maximum of random of 1 comma jdx. Okay. Okay, so here you can see 1 2 3 4. This is the I mean the uh, least I mean the time taken by the 4 workers. So this is actually uh, represent by them. Okay, so bytes received from workers by bytes sent to workers. Okay, bytes sent to workers, this is the bytes sent to workers and this is the bytes received to workers. Okay, so elapsed time is 0.61494. This is the elapsed time. So now it is important, that is called the parameter sweep. Already here you can see already you have seen that the parameter sweep of the parameter sweep and the plot the result. What is parameter sweep? What is parameter sweep? Now here you can see that this example shows how to perform a parameter sweep in parallel and plot progress during the parallel computation. Actually parallel sweep is basically you can call it as a technique. That technique is basically used to systematically vary input parameters of a model or input parameters of a system to observe the uh, resulting output or the resulting behavior. Okay, so if you vary the input parameters systematically of any system or any model, you will find that what is the behavior of the system, what is the output of that system. So it is basically the grid search across the parameter space. Okay, so here you can use the data queue. This is the function that is called data queue to monitor the result during the computation on a parallel pool. Already I have told you that if you change the input parameter, the output parameter will also change, and you can monitor what is the result is. Okay, so you can also use the data queue with parallel language features, that is the parfor, par par parfeval or and spmd. Okay, spmd. So here you can see that these examples how to perform a parameter sweep on a classical system, that is the van der Pol oscillator. So this van der Pol oscillator, this is the system that can be expressed as a set of ODE. ODE stands for ordinary differential equation. Okay, ordinary differential equation that is dependent on the two van der Pol oscillator parameters, that is mu and v. Okay, so here you can see the equation and you can perform the parallel parameter sweep over the parameters using the perfor loop to find out the mean period of y varying them. Okay, so here you can see this is mu, this is v values, and this is mu, this is new values mu, and this is mean period of y. So you can perform the parallel parameter sweep over the mu and nu using the perfor loop to find out the mean period of y when varying them. So we can vary the mu, these two values, and we can find out that what is the mean period of y. So here you can see that this is the grid size. We can assign the grid size. Okay, define the range of the values of the parameter to be explored, and that can create a mesh grid to account for the different combinations of the parameters. Okay, so this is the grid size. Grid size is 10. Linspace. What is the linspace? Linspace is basically create the linearly space vector. Okay, 100 comma 150 comma grid size. Grid size is 10, and this is the new value, this is the mu value. Simple thing, this is the new value, this is the mu value. Okay, now mesh grid. Okay, mesh grid is basically used for the mesh like grid structure, nu and comma mu, and finally you will get the finally you can create the mesh like grid structure. Now if you want to prepare a surface plot, if you want to prepare the surface plot, then you can use the function surf, surf. Okay, surf, surf. Okay, so to declare the variable to store the result of the sweep, use nan. Nan stands for the not a number for the parallel pre allocations to avoid the plotting and initial surface. Okay, Now create a surface plot to visualize the result of the sweep of each combinations of the parameters. Okay. So NN is the not a number. Okay. Which is basically used for the pre-allocations of the NN function is basically used for the pre-allocation to avoid the plotting and initial surface. Now this is the surface plotting. This is for the surface plotting. N, M, Z. Here N or M is created, mesh grid like structure is created, and Z is created for pre-allocation. So N comma Z. And after that I have labeled X label for X axis, Y axis, and Z axis. 1 minute. So for x-axis, y-axis, and z-axis, so yes, this is x label, this is x-axis, this is y-axis, this is z-axis. Okay, z label is specified by the mean period of y is specified by the z-axis. Okay, and you can view it. Now set up a data queue to fetch result during the parameter sweep. So what is data queue? Data queue is basically the function for creating the parallel pool object in MATLAB. So this actually help for asynchronous or automatic communications between the workers and the client in a parallel pool. Okay, so already I have told you that MATLAB client is there, MATLAB worker is there. So create a data queue to send intermediate result from workers to the client. This is very important. From workers to the client. So a parallel pool data queue is the object. You can say it is an object in MATLAB that actually provide the communication, the automatic communication between the MATLAB worker to the MATLAB client. Okay, in parallel pool. So it is very essential. It is very essential that a queue where workers can send the data and the client can process the data as it arrives. So after each function, here it is written after each function to define a callback in the client that updates the surface each time a worker sends the current result. Okay, so each time worker actually sends the current result. When the worker sends the current result, client receive it and can process the data as it arrives. Okay, so here that's why it is written D equal to parallel pool dot data parallel dot pool dot data queue. After that D dot after each at the rate x update surface c comma x. Okay, okay. Next, perform the parameter sweep and the plot the result. Perform the parallel parameter sweep and plot the result. So here it is written that for I equal to 1 colon numel within bracket n, then t comma y solve VDP in capital N II M capital II, and then L is local max y within bracket colon comma 2 value. So and mean of difference of 2 and send DII value and then end. So what does it mean? So this is the MATLAB code which basically utilizes the for loop. So this is here, the for loop is here that actually perform on perform for each element of n. So here I equal to 1 colon numeral n. So that means that this is a I mean the in vector n. So if I consider the n is a vector, okay, so n is a vector, so we can use the for loop to perform the each step for each element in the vector n. Now next thing is that the function calling, okay. So here we can use the solve VDP. Solve VDP is likely returning the time vector t and solution vector y. So here you can see that from here it will return the time vector t and the solution vector y. Next is local max. Is local max is what? Is local max basically identifies the local maxima in the second column of y. So colon comma 2 means what? First is the row, second is the column. So all rows, second column. Okay. So from this is local maximum, it actually identifies the local maxima in the second column of y. I mean the all rows should be considered, but only the second column is considered here. So second column of y, and then we have to find out the time difference. Okay, so diff uh diff I think for the differentiation. Diff is for the differentiation because uh, uh, 1 minute, if I am not wrong, diff is for the difference. I don't, just a minute. 1 minute. I think diff is for difference, if I am not wrong, or I think differentiation. Yes, I know that is for the differentiation, not for the difference. Yes. Okay, I will. I think it is the difference of the mean value. Maybe it is a difference of mean value. So let me clear this one. Just if I am not wrong, because I don't want to send any wrong message. And after that, the send function is there. Send function is basically sends the index ii and calculate the value. Calculate the val to the data q d. Okay. So just a minute. 1 minute. So this is basically the way to calculate the parameter sweep of this. Okay, similarly, if you want to scale up the cluster, you can scale up the cluster also. Okay. So helper function is basically helpful for to define the system of equation. Okay. If you want to update surface, you can create the function. Okay, create the function update surface, and after that you can create the function like that way. Okay. So this is about the parameter sweep, because as I have told you that parameter sweep is basically the technique. It's the technique where if we change any input parameters, we can see that output parameters, how the output parameters will change, how the output will behave. So that result will be represented in a grid search format, okay, in this parameter space, okay. So this is all about the parameter suite. One minute. Anjan? Just a minute, sir. তোমার কাছে আসিফের নাম্বারটা আছে? আসিফের নাম্বার আছে? আসিফের নাম্বার গ্রুপে আছে, ও আসিফকে ফোন করে বলো না আমি একটু বিজি আছি, ও পরপর 3বার ফোন করেছে আমাকে, ঠিক আছে? হ্যাঁ হ্যাঁ। হুম। তুমি একটু জেনে নাও তাহলে। Okay. So here already we have discussed on the parallel pool data queue object. Now this is the another function, or we can that is that how to getting the path eval. Okay, path eval. So this path eval basically used for the for creating the set up the parallel environment. Okay. So here you can see the parallel eval futures. Parallel eval futures is basically the object that actually represents the function that actually scheduled to run the parallel pool worker. So since there are two worker or the two futures in the queue, so each worker will start computing a task in the queue. Okay, each worker will start computing a task in the queue. So you can use the state property of a future to find out whether it is queued or not, queued or running or finished. So that state will be determined from this future. Okay. So here one. Okay. Just a minute. My computer is, yes. Okay. So here you can see that parp eval. So for get the future state. Okay. So if there are two workers or the three workers, so there and that two or three futures in the queue. So each worker will start the computing the task in the queue. Okay. So what will be the present state of the present state? So it will be at queued condition or running condition or the finish condition. So the state property uh, will be divulged or will be executed. Okay, will be executed from this command futures.state. Okay, so we can see that for the state to determine the state of the first worker. So futures one within bracket one dot state, we can see that it is at which condition, queued condition or finish condition or running condition. Okay. Similarly, parallel if eval parallel if eval q is basically another type of property, or you can say it as a object in MATLAB, that is basically collection of parallel if eval future object. Okay, so this is basically the future. This is basically these futures basically represents the task schedule for the execution on a parallel pool. Okay, so through this function it will basically try to uh, manage or monitor the task. Okay, uh, what is the condition of the task that is actually monitored by the if eval queue. Okay, so some computation in the pool queue can take much longer time to complete. So parf-eval is parf-eval by instructing workers to execute the functions pause 5 times, and where only the futures will with an even index will still take 1 second to compute as before. Okay. So using this parf-eval parallel eval queue object property, you can easily monitor the task, and this within this with this you can pause it for the 5 to 10 seconds. Okay, 5 second or 1 second, etc. Just so here first I clear the futures. Okay, clear the futures. If it is in the workspace, I can clear the futures. So here you can see that I want to pause the function for 5 times. So number in futures, okay, in futures is a 5. Okay, and number of outputs will be 0. So futures within bracket in futures parallel dot if eval future. Okay, and we can perform the for loop 1 colon in future. Okay, and after that we can run the if statement to find out the futures with even index, and we can rewrite the program line again. One minute. Okay. Last is the GPU computing. Just a minute. Actually, my computer is properly responding. Okay. Now here you can see. Here you can see in summary we can see that there are multi-core CPU. Okay. So using the multi-core CPU, we can it can implicit multi-threading in the underlying libraries. It can perform the parallelism using the multi-threaded MATLAB workers, and and parallelism can be done by using the MATLAB workers. But in case of GPU access via overloaded functions. So what is GPU computing? I am telling you that using NVIDIA GPUs with parallel computing toolbox. Actually, why GPUs? Okay, we have talked about the CPU, central processing unit. Okay, now why we are talked about the graphics processing unit? Graphics processing unit, because in case of GPU computing here, here you can see that it is more than simpler than a CPU. But here you can see that there has multiple cores. Okay, multiple cores, commonly 2000 plus cores, and it is ideal for massively parallel problems, and it is ideal for computationally intensive applications, especially for the deep learning application. Okay, and MATLAB advantages is that while I have talked about the GPU computing with MATLAB, MATLAB basically here offers a powerful environment as well as a user-friendly environment, which is basically speed up the computational task. Okay, computationally intensive task. Okay, and also by using the parallel computing toolbox. Already I have told you about the parallel computing toolbox. Here you can see 1 minute. Here you can see that this is the documentation of parallel computing toolbox. Please, this is the documentation of parallel computing toolbox. 1 minute. Yes, this is the computation of parallel computing toolbox. Yeah. Okay. So just try to go through this documentation of MATLAB. So here you can see that MATLAB has the advantage. Already 500 plus GPU enabled MATLAB functions are there, and also it is very simple in constructing the MATLAB based GPU problem. Okay, so there are MATLAB, there are one toolbox that is called the MATLAB parallel computing toolbox that is basically help to accelerate your MATLAB code without the need of deep CUDA programming. Okay, so here the main concept is that this is my device memory, this is the GPU cores. Okay, so here the GPU memory, I mean the GPU in GPU memory, GPU array basically an array which is basically stored in the memory. So this is called the GPU array, which is basically stored in the memory. And here you can see there will be some functions. This is the GPU array or gather. The inbuilt GPU accelerated functions are there, built-in MATLAB functions are there, which basically support the GPU arrays. And automatically you can offloading the computations to the GPUs. So here you can run the same code. Like if you want to solve any 2D wave equation, in CPU or in GPU. So here you can see that if you want to run solving 2D wave program, okay, so there we can involve the 4 cores with the bandwidth of 25.6 gigabyte per second. But in case of GPU, while we can use the NVIDIA GPU, okay, NVIDIA Tesla K20C, K20C, here you can use the 2496 cores, okay, 2496 cores, and the memory bandwidth is 208 GB per second, 208 GB per second. So time is almost the 20 times faster, okay, 20 times faster. So this is the computation time. I mean that here you can see, that by using the in case of GPU computing, whatever be my task, that kind of task can be easily performed, and it will accelerate the performance, okay. And also this GPU array basically convert the data, I mean the into the GPU array to transfer it to the graphics processing unit, okay. So there are different types of functions, GPU accelerated functions, which is basically help to perform the calculations on the GPU array, okay. So here you can see that speeding up the MATLAB applications with GPUs, here you can see that for k-means clustering algorithm, so 10 times higher, the speed up is 10 times higher. Template matching, okay, template matching, for template matching the speed can be 14 times higher. Similarly, for these applications, black scrollless model, so it is 12 times higher. Or simulating the movement of celestial object, okay. So if I want to see in the scatter plotting, okay, so that kind of simulations or the movement of this celestial object will be visualized by using this kind of NVIDIA GPU Intel Core processor, okay. So in MATLAB you have to type the GPU device, okay. If you see a CUDA device, you are good to go, okay. Otherwise you can type the GPU device, and if you type the GPU device, you can see the property of it, okay. If you see a CUDA device, you are good to go. And here you can see the compute capability, or maximum thread per block, toolkit version, driver version, clock rate uh, in kilohertz, okay, total memory or the available memory. So that kind of information, property informations you can get if you type the MATLAB code the GPU device, okay. So generally this MATLAB code perform the following steps, that it will uh, convert, basically help to convert the any matrix to the GPU array, okay. And it actually performs the element wise. So here this is the demo that I want to show you. So if you type here GPU device, then you can get the information NVIDIA GeForce GTX 1070 with its capability, driver version, etc. Okay. Next, this is the approach GPU computing. That is Mandelbrot set, okay, where you can see the using of this algorithm with the GPU data as input. Next is the array function. Array function is there. Okay, so GPU array is basically helps this to transfer the data between the CPU and the GPU. Okay, so here maximum iteration is 500. We have to create the 100,000 cross 1000 grid of the real parts and imaginary parts, which can be created within these limits. And Mandelbrot algorithm is iterated at each grid location. So here 500 iterations will be enough. Okay, so here I have taken the maximum iteration is 500. Maximum iteration is 500. Okay, just a minute. And here the grid size is 1000. Okay, because 1000 cross 1000, if it is a grid size, is 1000. And here limit of x and the limit of y. So here I have represented the x lim and the y lim. Okay, now next I have written here the t is equal to tic tick, then linspace x lim comma y x lim 1 comma x lim 2, then grid size y lim comma y lim 2 in the grid size, then mesh grid of x and y. Okay, so now I type here z0 equal to x grid, then I into one I into y grid. So this is basically x grid plus y grid, that is the real and imaginary. Because 1000 cross 1000, I have created the real elements and as well as the imaginary elements. So z is the complex part. So x plus if I have considered x plus iy, so z equal to represented by that way, and then count equal to one's size z0. Okay, next if I want to calculate the count, then I have to write z equal to z0 for n equal to 0 maximum iteration, then element wise multiplication z into z dot star z plus z0. Okay, then I have found what is the what is inside. Inside is the absolute value, which is less than equal to 2. Then count will be iterated, count plus inside, and then end. And then I find the count value of its logarithmic with its logarithmic value. Okay. So here if you want to open any documentation, you just type here doc Mandelbrot. So then you can get the logarithmic the documentation of it. So this is the GPU computing. Here basically we want to convert, or we want to create the random matrix. We want to transfer it, we want to convert the matrix to the GPU array and transfer back to the CPU, and after that we have to display the variable informations in MATLAB. Okay, and here you can see this is the GPU computing. So this is GPU computing with MATLAB. So GPU computing with MATLAB. Okay, so here you have see the different types of applications that can be easily performed by the GPUs. Okay, And yes, there are difference between the CPU and GPU. And if you want to get informations about the GPU device, you have to write in the command window, that is the GPU underscore device. If you want to program in MATLAB, you have to follow this workflow, that create the data on the GPU, then perform the calculation, retrieve the data again to CPU. Okay. So here, this is the way that if you want to create the random number, first you have to create the random number in that way. Then you can create the GPU array. Okay, GPU array like that way. You can perform the calculations and gather the data to CPU. Okay. So this type of execution, GPU execution options are available in this toolbox. Okay, like card fitting toolbox, wavelet toolbox, if you want to perform it. So there will be the certain functions with the GPU array support. So if you want to perform the machine learning with machine learning toolbox, there will be the certain functions of the GPU array support. Similarly, for the deep learning applications, for computer vision application, or for audio toolbox, you will find that kind of application. Okay, if you want to compute any FFT, fast Fourier transformation on a random matrix, okay, so that is also can be possible. So thank you. So here I want to conclude my session. So these are the user story. Okay. Any questions, sir?
Dear participant, session is open for discussion. If you have any question, please feel free to ask. You can unmute your mic and then ask directly, or either you can raise your hand. Also, you can put your question in the chat box. I request to all the participants, if you have any kind of question, please feel free to ask. Yes, anyone can unmute your mic. Anyone, please?
Okay. Participants, my suggestion is that you can follow the parallel computing toolbox that is available in the MATLAB documentation page. Okay. There, I think I will try to cover the agenda, and I think I have give you the brief of about the parallel computing toolbox and some relevant example and the codes that I have shown to you. Okay, so I will share with sir. But before that, of course I recommend you that this type of application, I think it is visible to you. So these are the application, or these are the examples that you can see. Okay, see in the documentation page. Okay, so just now I have shown to you the Mandelbrot algorithm. Okay, so that kind of MATLAB code is available here. Okay, also if you want to know more about the parallel computing toolbox, so here you can see that the parallel computing, go to the parallel computing, and uh, here you will find the parallel computing toolbox. Okay, so you can open this one. open the parallel computing toolbox, you may know the which functions are required basically for the uh, for this performance, like for the parallel loop, parallel for loop. I have already told you about the parallel for loop, for parallel programming, even for the big data processing, though it is not included here. Okay, but if you want to analyze the big data set, okay, so in parallel way, so you can use the distributed arrays, tall arrays. This is also the good example on Spark and Hadoop clusters. Okay, so this is another important thing. And also the GPU computing, how you can accelerate your code by running it on the GPU. Okay, so there are uh, uh, well, while there are 4 cores. So in case of GPU, there are multiple cores which basically accelerate your code. Okay, so it will enhance the performance. So how you can improve the performance with the MATLAB code. Okay, so that type of information you can get from here. If you click on it, you can see the different types of examples here. Okay, so different types of examples you can open in the live script format. Say if you click on it, if you click on it, then you can find out that type of examples. Okay, that examples, and it is well documented. I recommend you to follow this documentation. Okay, I think it will be good for you. So thank you so much. Thank you for patience. Here I conclude.
Cleva, you can unmute your mic.
Okay, thank you, sir. Thank you for your presentation.
Yes, sir.
It was very interesting. So, however, I would like to have more insight, like more clarification on the par for loop. For example, in neural network, if I would like to maybe optimize the number of neuron in the hidden layer. Like sometimes I'm using the for loop. I don't know. In that case, should I use the path for loop as you said? For example, maybe I will say maybe I will loop from 5 neuron to maybe 20 neuron in maybe in the first hidden layer. So in that case, should I use the path for loop or it's simply the simple for loop? Thank you.
Uh, uh, Sir, thank you, sir. Thank you for your question. So basically for deep neural network, generally there are 3 layers. One is the input layer, hidden layer, and the output layer. And your question is that you try to optimize the hidden layer. Yes, sir.
Yeah, no, I'm trying to optimize the number of neuron in the
Number of
hidden layer.
neurons. Okay, number of neurons. Okay. So number of neurons. Yes, sir. It is possible because already I have told you that basically in case of deep neural network, there are number of neurons. Okay, number of neurons, and if you suppose I want to perform perform in the GPU computing. Okay, with the deep learning toolbox, there will be a certain function. Okay, my computer is little bit slow. I am showing you. Just a minute. I am showing you. Uh, there is a certain option. Just a minute. If you have you handled the deep neural network toolbox, deep network designer toolbox, or network designer app? Hello, sir.
No. Yeah. No.
No. Deep neural. Okay, sir. Sir, here here there is an option, because I have already told you that statistic machine learning toolbox or the audio toolbox or the deep learning toolbox, there is a certain function. If you try to do the GPU computing, there is a particular function which can perform on this particular toolbox with this particular toolbox. Now there is a apps that is basically help to help to decide the number of neurons, or by using the deep network designer app. So here you can see that this is my deep network designer. Is it visible, sir? Deep network designer, deep network designer. So if you click on open, if you click on it, then you will find, 1 minute, sir. If you open, you will find some pre-built network. Okay, pre-built network. Okay, there, or you can see that there are number of components in the component library. Okay, where you can see that you can assign the number of neurons. Okay, number of neurons, number of hidden layers, or number of parameters. You can optimize it. Okay, now you can generate the code also. From here, you can generate the code and you can optimize it. Here you can, if you type here, just a minute, my computer is little bit slow. uh, 1 minute, sir. One minute, sir. One minute. Image processing. Where is the deep learning? Or fitting deep learning toolbox. I think this is the way. Just a minute. 1 minute.
Okay.
1 minute. So this is the way. Here you can see that this is the multiple GPU. Some command is there. Just a minute, sir. I am showing you. Just to, okay. Um, So basically MATLAB, if you open MATLAB here you can see that the Deep Network Designer app is there. Deep Network Designer. You can using the Deep Network Designer app. There is a suppose in Deep Network Designer. If I consider the total network, there is an input layer and there is a hidden layer, and in hidden layer you will find the convolution layer, ReLU layer, max pooling layer, max pooling layer, or average pooling layer. Okay. Similarly, the soft max layer. So there are different types of layers are there, and also you can optimize the hidden neurons also. Okay. So from here you can generate. First of all, you can generate the code, and after that, if it is the if you want to process in GPU based application, then here you can use some multiple GPU option. Okay, so here using that function. If you have the machines like multiple GPUs, you can train the network with the trainnet function, and by setting the executive environment with the training options. Like that way, you can process through the process your network with the GPU based environment. Yes, this is the here you can see, sir. Here you can see. Here you can see. You can first create that, train the multiple networks on the multiple GPUs. Like that way, you can create that environment, and after that you can perform on it. Basically, from that app you can create your own model. You can customize your yes. So just a minute, sir. Just a minute. Uh, 1 minute. Sir, it is visible, sir? It
Yes,
is
yes.
visible? Yeah. Sir, this is the Deep Network Designer app. Okay. So now I can say like that way that you can build your own model, build your own network, blank network. If you click on the blank network, then this type of window will open. Okay. And here you can see that in this layer library, you can see the input size. Is it visible, sir, properly? Is it visible, sir?
Yeah, I'm seeing, yeah. Okay, now it's better. Yeah.
Yes. Yes. So here you can see that this is the input size, the other parameters are there. Okay, you can try it from your end. Okay, try it from your end. Okay, and this is the layer library. You can add your layers, okay, to build a network, or there will be a pre-trained network is there. Pre-trained network. Yes, pre-trained network is there. If you have the MathWorks account, you can download and install that network. Only there is some pretend network is there, okay, pre-built network, okay, you can use it, or also you can create your own network, okay. So now next thing is that here there is an option to change the number of hidden units or hidden layers, or you can optimize the number of neurons also. There is a options, okay, you can change that option, okay. And after that you can create that type of network in the network designer app, okay. So here you can see the number of layers, number of connections. Number of connection is 4. The input size and output type is classification, okay. So that type of network should be created, okay. So you can write by the script also, or you can use that app, okay. uh, but the important thing is that suppose I want to use that kind of written network, so just type the net equal to AlexNet, or net equal to Google Net, or net equal to ResNet, okay. And after that you can import it by changing, if you want to change any parameter. And if you want to export it, then automatically all the code behind this every block will be represented in the form of will be represented in the form of function, or in the form of code. I mean, whole code will be generated, whole code. So if you click on the export, then there will be the option that is the generate code option, and there you will find the every parameter details, okay. There will be the every parameter details, like number of layers, number of connections, number of neurons, so that thing you can change, okay. So this can be done. I am showing you this thing, okay. And after that you should create, because I 1 minute, you should create that environment, okay. I mean the GPU based environment, okay. So if you create the GPU based environment, then the train network will support the multiple GPU, okay. And using the parallel computing toolbox, you can perform it in the GPU platform for training purposes. But here it is important that MATLAB has the capability to perform this. I mean that if you want to perform any deep learning network, or deep neural network in this MATLAB platform, it can be performed easily. And after that, here you can see that this is the code that can be generated from here, okay. That can be generated from here. Okay, and you can optimize it. Okay, sir.
Yeah, thank you, sir.
Okay.
I think all the questions has been
Hello,
discussed.
hello, sir. Hello,
Hello.
sir.
Yeah.
Yes, yes. This is Dr. Diko from University of Ibadan in Nigeria. First, I I must appreciate the lecturer for such very good, beautiful presentation, and must also appreciate Professor Meher Chand for the privilege he has given us, because this is my first time of having interaction with computational neural networks as it is being described. I know I will need some help, because at the beginning it was quite rigorous for me because of the basis, which about network analysis that I am not too good with, which I am just seeing, maybe some for the first time. So I would appreciate if two things. The lecturer can refer us to some of his works so that some of these real application that has been done, maybe by him or some other authors, which can help us bridge basics of the theory and the computations. That's one. Then
Okay.
I also want him to maybe just describe in some few words. When he started with network analysis about the computer architect. I mean, that the theoretical knowledge of the memory, space, and all those things. Why do we need that? That's the question. Why do we need that? I mean, for these computational methods. Because I'm trying to ask myself that is it that the data will be so much that somebody, a programmer who wants to write a code for MATLAB would need to go and check the compatibility of the system or what? I mean, I'm just trying to, relate the two. That's why I needed to ask this question. Thank you very much. I appreciate your efforts. God bless you, sir.
Thanks.
Thank you, Dr. Deco.
Thank you, sir.
I think if you have any question, we have many discussions today. And if still there is any question from any participant side, please feel free to ask. Otherwise, it is the time to over the session. I think there is no more question from the participant side. And thank you, Mr. Pickon Majumdar, for this nice session, and questions from the participant has been discussed. And I hope that the content which we delivered today, very helpful, informative, knowledgeable to all the participants who are attending this session. And till date, the content, except today, all the content up to 10th day, 11 also has been uploaded, 11 to 12. So you can easily access from the link which we have already provided to all the participants. Also, all the recordings of the sessions are available. Link shared with you. You can easily access anytime through the recordings which are available on the YouTube channel, which is officially YouTube channel of the Mathematics Thinking Foundation. We create one playlist so that you can easily go through day-wise all the lectures. And in the Google Drive also, you can easily find all the day-wise content. And only the MATLAB is very vast and various type of the applications, as you can see. And we try to touch every area domain of the MATLAB. So, and because the participants are from different domain, and some are from the computer science, some are from physical science, some are engineers, some are mathematician, and majority of the participants are from the mathematics background. Okay, so everything we are trying to cover so that we can demonstrate everything. And I hope that the way which we are trying for the better understanding for all the participants is going well. Still, because there are always some challenges when we organize this type of the event online mode, and just like today, we have a long session. Regularly, we have only 2 hours, but sometimes the speaker have good content, and they want to present everything which they have prepared for the participant. So in that case, we all have to keep patience. And if there is any question from the your side, or you want to ask more, And if in future, because everything not possible within 14 days, because we have partial content from a different domain. Okay. And when we go for the specific, it will take more time again. Meaning to say, if you have any problem in the future also, you can contact us, and our team, the speakers, will surely help you to your future work, as well as to build the network. And if we have good network, then we can support each other, and we can have the solution for the problem without any loss of time. So once again, thank you to all the participants for having patience and to attend this entire session. The feedback form and the quiz has been shared in the WhatsApp group. You can submit. We left only 2 sessions. One session will be missed by Dr. B.S. Ratnawal. So in the place of B.S. Ratnapal, Dr. Shalu will take tomorrow's session. And then after, we have the last day on 31st July, and Dr. Professor Jakia Hamouch will be there to deliver her lecture. So once again, thank you to all, and stay connected. Tomorrow we will start the session at the same time. Thank you very much once again.
Thank you very much.
Thank you, sir.
Thank you,
Thank you, sir, for your long discussion, and a lot of time you have spared for today's session, as well as
Yes.
in the previous 2 sessions. Your session are always very long, and I think the content which you prepare, we need more time for the long discussion, and hopefully in the near future we will organize offline event, and we will invite you, because when we have the specific event, and when we have the full day to discuss on these things, then we have more understanding about the content. So once again, thank you, Mr.
Yes, sir.
Pickon Majumdar, for your nice presentation and everything you demonstrate in very detail. And I hope that all the participants have very informative knowledge from your content. Once again, thank you to all. Thank you very much.
Thank you.